Hello, my name is Andrew Grau, and this is my Physics 1 public lecture review. The lecture that I watched was Pattern Formation in Nature and Why is the Universe Not Boring? So, kind of an overview of the lecture. So, it was given by Stephen Morris a few years ago, and it explores the emergent behavior and patterns that the universe has to offer. And Morris explains how these patterns were discovered and tested through experimentation. So, kind of when I was going through this video, he was talking a lot about the patterns that were emulated in space and also here on Earth through nature. He talked a lot about evolution, and he also talked a lot about kind of how everything's constantly evolving until the end, until something goes extinct, and how all of this emergent behavior is really unknown. We don't really know what causes it. Or at least how to predict it. And I thought that was very interesting. But kind of a big piece of new knowledge learned was that the universe is out of balance and that this is applied to all aspects of the universe, and that nature has these emergent patterns that are very similar in structure but differ in medium. So they often have kind of shared shapes, a lot with this convection example that Morris used. It's either hexagonal or square, depending on like the certain situations, or it's a striped pattern. And there was a lot of talk also with his example with different types of sand falling into a glass enclosure that also created a striped pattern. And there was a lot of talk of that, obviously covering different mediums, but going over multiple cases and examples. So, kind of expounding on existing knowledge, something that I thought was really interesting was he actually talked about Faraday waves, which I have seen before when, like, you're grabbing a cup on the other side of the table and you pull it towards you, and that vertical vibration causes Faraday waves. But I'd never put a name to that phenomenon. So, watching the lecture and hearing him talk about that was really, really interesting. And kind of how he talked about how they only occur above a critical acceleration threshold, and it is only caused by vertical vibration. And then if you look at it from a certain angle, it's often forms squares or hexagons. So I thought that was very interesting, and it was really cool to kind of have that be emulated in a more rigorous and academic way than just, oh, I moved a cup across the table and I saw this cool phenomenon. So it was cool for him to kind of build on that concept for me. So another point that really sparked my curiosity was him talking about the beach cusps. So I actually don't know if I've ever seen these before. I didn't really commit it to memory if I did. But when he was talking about them, I was really interested. And what I really found interesting was how he mentioned if you start with just a flat beach, eventually like kind of a small bit of sand will get displaced, and then that'll become a trough or a peak, and then gradually over time it'll build to this these large cusps in the sand in the beachfront, which I thought was very interesting. Then he also talked a little bit about segregation, specifically with materials on these beach cusps. So he showed an image of like rocks versus sand, where the sand was in kind of one, and then the rocks was in the other, and they were kind of alternating, showing a pattern in there as well, which is really interesting. So, relation to my personal field of study, so what he was talking about, kind of emergent behavior in nature and at a universal scale, wasn't particularly related to my field of study. I'm an electrical engineer, but I'm sure there are emergent behaviors that show up in voltage graphs or current waves and things like that that definitely would be applicable to my field of study. So, kind of to end off, something that I wish that the lecturer might have touched on a little bit was kind of like solutions or the predictability of all of these phenomenon, or at least some of them. So, often he would explain a phenomenon, show images, kind of give some reasoning for why this is happening. Um, or what might cause it, and then he'll be like, so do we understand why it does this? And then he would say, no, we don't. And I mean, I understand that from a research perspective. Obviously you don't know what causes everything, but I kind of wish that he might have mentioned some attempts that might be made by researchers now or in the past that might have failed, or maybe still have prospects left that are trying to work at explaining how this all works. But I also understand that that's not really in his control if there really is no research being done, which he kind of touched on at the end of his lecture, how he mentioned a book, and he's talking about how that's really the only non very academic book that you can get on the subject. So definitely a niche subject, but a very interesting lecture. And I thought it was really profound and really eye-opening to kind of some physical phenomena that you see maybe in your everyday life, or maybe when you're on vacation, or just in these small moments. And he really kind of brought the science into that and explained why that happens, and gave it a name and explains the experiments that proved why it works, and kind of patterns that emerge from it. So I thought it was very interesting. Thank you.